Hello friends, how are you? In yesterday class we discussed two theories related about acid-base concept. That was Arrhenius theory and second was Bronsted-Lowry theory. In today's class I am starting the third theory which is very important for our exam, that is Lewis concept of acid and base. It is Lewis concept of acid and base. As compared to two theories which was Arrhenius and Bronsted-Lowry theory, it is easier but it is very important for exam. And how the questions comes in paper we will discuss later on. Firstly we discuss about this theory, Lewis base acid concept. This theory was given by Lewis in 1923. According to this theory, acids are those substances that accept that accept electron pair, while bases are those substances that donate electron pair. That means electron acceptor are acids, electron donor that are bases. Okay, to understand it, there is an example here. A and B, there are two chemical species A and B. A is donating electron pair to B and make a coordinate bond. As you know, there are various kind of bonds: ionic bond, metallic bond, coordinate bond, covalent bonds, and coordinate bond in which the bonding electrons is donated by one but shared by both atoms. Such kind of bonds are known as coordinate bond. We discuss in class 9th. So here the bonding electron is donated by A and shared by both, so it is a coordinate bond. Okay, and formed compound is coordinate compound. Again I am coming in the example, A donating electron pair to the B. So A is donating, so as per the definition it is base, while B is receiving, accepting, that is acid. So A is here base and B is acid. Okay, according to this theory, acid and base are attached by coordinate bond as I discussed earlier and give coordinate compound. The compound formed is coordinate compound. Now the question comes in our mind that which atom or chemical species or ions can donate electron or which can accept. That means which substances comes in the category of acids and which are in bases. Since bases are electron pair donor, so they must have extra electron, while acids are electron pair acceptor, so they should have deficiency of electrons. Bases, two types of chemical species comes in this category. One are anion, and you know that anion have negative charge, that means they have excess of electrons, so they comes in the category of bases. And second, electron rich compound having lone pair like NS3H2O. And lone pair are pair of electron which are not used by an atom in making chemical bonds. Okay, electrons pairs which present on an atom and not used by atom to make chemical bonds are known as lone pair. So they have these extra electrons, so they can donate, so they comes in the category of bases. Now acids, they are electron acceptors, so they have deficiency of electron. So two type of chemical species comes in the category of Lewis acid. One are cation like Na plus, Mg plus 2, Ca plus 2, Al plus 3. Because of the positive charge they have deficiency of electrons. Second, that are electron deficient compounds. These also come in the category of that. Like the example is electron deficient compound, that means having incomplete octet. Example BF3AlCl3. Like to describe it, let me take BF3 example here. Boron is chemically bonded with 3 fluorine atom by single bonds. As you know, boron is the hydrogen, helium, lithium, beryllium, boron. Fifth one, so its electron configuration is 2 and 3. So outermost have 3 electrons. Now it is bonded with the 3 fluorine atoms, and you know that by making single bond, one extra electron is obtained. So by 3 it obtained 3 more. So total is 6 in BF3. In outermost shell there is a 6 electron in BF3, but as you know, to stability they must have 8 electrons, so there is deficiency of electron. Similarly, like that, aluminium also have outermost, that is 3 electrons, and by making 3 single bonds with chlorine it received 3 more, so total is 6. Again, that is incomplete octet. So these examples comes in the category of electron deficient compound. Now, how an acid and base react with each other? To understand it, I am taking one example, NS3, which was a base combined with react with BF3. Here nitrogen have one lone pair, oxygen have two lone pair. Okay, uh, that is 2. Now come again on example, NS3 plus BF3. NS3 have one lone pair, boron, that is electron deficient compound, electron deficient. So nitrogen give the lone pair to the boron and make coordinate bond. Here it is donating, so it is base, it is receiving, so it is acid. So this compound is formed. Got it? In which nitrogen and boron, they have a coordinate bond between them. Clear? Now comes on our exam purpose. Normally, this theory directly asked by the examiner, that explain the Lewis-Bayes concept of acid and base. Lewis concept of acid and base. But sometimes there are some examples given and asked to separate them, either they are acid or either they are base. Like there is Br negative, Al plus 3, H2O and AlCl3. Now, the examiner asked that separate them in acid and base. So for that you have to notice some things, that if there is negative charge or there is a presence of electron pair, then that's come in the category of base. But if there is positive charge or electron deficient species, then it's come in the category of acid. So that kind of questions comes in our paper. Okay, now move to the next topic, that is general property of acid and base. First property, that is taste. As we discussed earlier, acids are those chemicals which are sour in taste, while bases are those which are bitter in taste. Okay, second is litmus test. Acids turn blue litmus to red, while bases turns red litmus to blue. Okay, third property, ions. Acid produce H plus ion, bases produce OH negative ions. These are general properties we discussed 2 or 3 times in the previous classes. Now fourth one, that is reaction with metal. This is a very important question for exam purpose. Acid or base when react with metal, then they produce respective salt and hydrogen gas. When acid and base react with metal, they produce respective salt and hydrogen gas. For example, this first example is very important for exam, because it is asked 2 times. It asked 2 times. HCl plus Zn. Here zinc is more reactive to its substitute hydrogen. Zinc has bivalent, that is +2, hydrogen is +1. So it can substitute 2 hydrogens and make ZnCl2. The 2 hydrogens which are substituted now combine and make H2. Similarly here, Mg normally found in +2 state, hydrogen in +1 state. So make magnesium, substitute 2 hydrogens and make MgNO3 twice. Okay. Since acid react with the most of metals, therefore there is one questions in exam which asks frequently that why the acids or sour materials should not kept in metal containers. So that is the answer, because of on the basis of that reactions. Acids react with the most of metals, therefore sour or acidic substances are not kept in metal containers. Okay, that is a question for you. Now one more, that is a frequent question for your exam. This diagram asked by board, I think, one time, and this reaction is asked 2 times. So that is a very important activity for you. This is an activity which showing that how the acid react with base. Sorry, how the acid react with metal. For this, we take a test tube, put in a stand, attach a cork with a flow tube or delivery tube, which open in a soap solution. Now put some zinc granules in it and add dilute hydrochloric acid, sorry, dilute H2SO4. We can also put to hydrochloric acid, that depends on us, but as per the our textbook, that is a sulfuric acid. So these, that is added. Now there is a bubble formation, which the bubble formation, that is a gas which comes out from delivery tube, and here it is appear as the bubbles. Which gas is that? For that we do a burning test. In burning, when a candle or matchstick comes near to these bubbles, then pop sound, let me clear you, which is pop sound is giving. Pop sound is the identification of hydrogen gas. That question asked in a board. That question asked in board. Okay. So here it producing pop sound. Okay, the pop sound is the identification of hydrogen gas. If that is the hydrogen gas, then it is only possible when it is substituted by metal. Without the substituting, how can it come out? So this activity cleared that when acid react with the metal, then it produce hydrogen gas and respective salt. If we write the chemical reaction of this activity, then H2SO4 react with the zinc and make ZnSO4 plus H2. Okay. Like acid, some bases also react with some metal, but there are certain bases and certain metals. Let me clear you that. Okay. They also react with each other. For example, NaOH react with zinc. This is very important reaction for your exam purpose. Okay. This is very important because that is a frequent question of board. Write the chemical reaction when zinc react with NaOH, or the compound name. On the basis of compound name, that reaction can also ask that write the chemical reaction of making of sodium zincate. Okay, so NaOH react with the zinc and it formed Na2ZnO2. Na2ZnO2. It is like that. The hydrogen is substituted by zinc. Again, zinc can substitute 2 hydrogens. So it combine remaining part, that is ZnONa, ZnONa. If we combine Na2 ZnO2, okay, so this is compound. So that is very important reaction. Okay, now fifth property that we discussed earlier, that is neutralization reaction. When acid react with the base, then they make salt and water. That is HCl plus NaOH, that is NaCl plus H2O. Okay, so that is the fifth property. Hope you enjoy it. Thank you.